We have the following problem here where we have an equilibrium and we have a set of concentrations. Remembering that if it's in brackets, bracket means molarity or pressure. And in this case, we're going to call these molarities. So we have the reaction of methane, CH4, with oxygen producing carbon dioxide and two waters. And we can tell that it is a equilibrium because the equation has a double arrow, which means that there is a forward reaction and a reverse reaction. And we have the concentration we want to find, K. So there's a two-step process to this. This is pretty much what it's all about. First step is you have to write out the equilibrium expression. Now remember that K is products over reactants. Now, hopefully, you know which side the products are on. The products are on the right-hand side. Here they are. And the reactants are always on the left-hand side. And so remember that whatever we have in front of the reactants and the products goes as an exponent. So we can write this out. So we say K is equal to, let's see, products, we have CO2 and water, and we say bracket CO2, that's where we're going to put that concentration for CO2, times the H2O concentration, and we're going to pull down that 2 and put it as an exponent, and there it is. We're always multiplying, we're never adding. Even though we have a plus up here, that doesn't mean anything as far as equilibrium expression goes. Now, we do reactants, and that is the methane, CH4, times the oxygen, and it's also going to have a 2 as an exponent. And so now, all we have to do, now that we have the correct equilibrium expression, is plug in our numbers. And we have to just be able to put it into our calculator. So you should do this on your calculator and make sure you get the same answer with your calculator. So we carefully go up and we find where CO2 is equal to what? And that's 1.50. So we say 1.50. And then that's going to be times the H2O, which is 2.0. But we're going to take that to the second power. And many keyboards on calculators, you would have a caret key, and then you would put the 2. And then we're going to divide by everything on the bottom, carefully putting it into parentheses to force the calculator to keep them on the bottom. And we find our CH4, there it is, and that's 0.200. And that's going to be times the O2 concentration, which is 0.300, and that's also to the second power. Then we close the parentheses. I've seen people put the 2 on the outside, and that would end up squaring up everything on the inside. So put this in your calculator and make sure you can get the same answer with your calculator. Half the battle is being able to use your calculator. So it's 1.5 times 2, caret key up squared, and then divided by everything on the bottom in parentheses, 0.2 times 0.3 to the second, close parentheses, and that gives me 333 for a K. And then finally, now that we found the K, what does that K mean? Well, we know that if K is greater than 1, that means mostly products. And if K is less than 1, that means mostly reactants. So what do we have here? Well, that 333 is a lot bigger than 1, so this is mostly products. So make sure you know how to use your calculator. Setting up the K, as long as you have the balanced equation, you can set up the equilibrium expression. And then it's a matter of just plugging in the numbers that are given to you to get the K as your final answer. And then you should be able to say, well, what does that K mean? If I have a K that's bigger than 1, then I know that it's going to be mostly products.